captain's competition in order to determine the order in which you will be choosing the role for this fight. So I will read the question, then I will also copy it in the text channel, and afterwards you will have only 15 seconds to answer to me in private messages the answer. The answer is the number, and who will be the closest in the absolute value with the number, it will be the winner of the competition. So the question is from Valeria Lukashenko. Since she's working with CERN, the CERN is the Conseil Européen pour la Recherche Nucléaire, or European Organization for Nuclear Research, and also it's a host of the Hadron Collider. And the question is, how many CPUs cores does CERN use? Time. Three, two, one. Okay, unfortunately, I've got only two answers, so the third team will be the last one. So the team Phoenix gave an answer of 2000 cores. I would say it's pretty low, but the team Reimaging gave answer of just 300 cores, which is even lower. The correct answer is, I will duplicate, no, I won't duplicate it. The correct answer is 230,000 of cores. So it's much more than you estimated, but still Team Phoenix is the winner of the competition. And in which order, Team Phoenix, you want to choose the role in this fight? You want to choose
For the second.
You want to choose second. Okay, Team Phoenix, Team Reimaging, you want to choose first or third?
First.
Okay, then do your choice.
In the first round, we want to be reporters.
In the first round, you want to be reporter. Quite interesting. Okay, Team Phoenix, in the first round, you want to be opponent or reviewer?
Okay. We want to be. Can I have a minute, please? Only 1 minute.
Please. No, only 10 seconds.
Okay. Okay, we will be an opponent. Okay, opponent. Yeah, we will be opponent.
Okay, so Team Phoenix is opponent, and the Team Bazinga, it's a reviewer. So I need just a few seconds. So Team Reimaging and Phoenix will be opponents. So Phoenix. Okay, so Team Phoenix, you can choose, you can challenge the reporter with the task, except task number 3, 5, 6, 10, 11, and 12.
Okay, we challenge the team to the for the task number 9. It's about artifacts.
Yes, task number 9, Team Reimaging.
Eternal rejection.
Okay.
Oh, okay. So I'm trying to find the list of tasks as I don't remember the numbers, to be honest.
You can open the list in front of you. So I will upload the except with the task number 9. So now you have only 5 tasks left. It's task 1, 2, 4, 7, and 8, which is available. 1, 2, 4, 7, 8.
Okay. And We can't use the first and the eight as we do, and the
Tell me why you can't use the first?
as we were a reporter of
No.
this.
So you can't. Uh, I'm telling you which you can or which you can't. If you read the rules correctly, they're
Uh-huh.
saying that you can't choose the task which reporter already reported or which you already opposed. If you reported some task, it doesn't mean that you can't be opponent for this task. So like
Ah,
you can
o-
use any number except which I stated. That's why I'm actually sitting
okay,
here and
okay.
writing you
Thank
this
you,
number.
thank you. We challenge for the task number 4.
Task number 4, universal transforming agent.
Yeah,
We accept the challenge.
thank you.
Okay, so task number 4 is accepted perfectly. So now, dear reporter, your time for the preparation for the report is starting, and I'm asking all the teams to write the names of the reporter, opponent, and reviewer. And then when everything will be ready, we will start the report. Yeah, and I'm asking once more if there are possibility for any player or jury who is participating to turn on the camera while he is speaking. It's better to do it.
Good afternoon. Can you? Yes. Can you hear?
Wait, so first question, okay, we can, if everyone can hear you, see you, and if everyone can see the presentation. Other people who are not seeing the presentation or not hearing the reporter. Seems not, which means that I'm giving you your 10 minutes for the report
Wait,
and
please.
there.
May I request a second or just another for preparation?
Can you repeat, please?
Another second for preparation. Uh,
For what?
okay, I'm ready to start. Can you hear me now?
Yes, but the question is, you are showing the presentation, but we are seeing the PowerPoint. We are not seeing the full screen of the presentation. Is it okay, or is it how it should be, or not?
As for now, it's okay.
Okay. So you can start. Your 10 minutes is starting right now, please.
Okay, so my name is Daria Shishko, and today I am a reporter. Today I'm reporting task number 4, which is Universal Transforming Agent. I represent team Reimagine, and here's our solution. So here you can see now the objective of our work. As all of us know, we need to suggest a protocol that would be appropriate for the greatest part of eukaryotes, as well as require a short period of recovery for the transformed cells. We need also to have a stable method of DNA transfection. So first of all, we are going to analyze a few of present technologies. Um, there are a few approaches actually: biological, chemical, physical, and mechanical. Some of the methods are of very narrow range of applications. Some of the methods can cause the high level of cell death, and some of those are low efficient. So now let's take a look onto main cons of the most used methods of transfection. DNA transfection by electroporation is an established technique that is applicable to perhaps all the cell types. It yields a high frequency of stable transformations, not so high actually, and has high efficiency of transition gen efficiency expression. This creates this method consists of creating pores in the membrane, and during the time that the pores are open, a nucleic acid can enter the cell and ultimately the nucleus. The technique was even generalized to all the cell types, such as lymphocytes or fibroblasts, and also for plants and fungi. But as you can see on the slide, the transformation efficiency after such transfection is pretty low. It depends on cell type, but numbers are still really small. For fibroblasts, recuperation gives, for example, a stable frequency of 1,000th of uh, percent, and the evaluation of this of expression after such a delivery can be for hours, days, weeks, or months. Besides, this method requires quite special equipment. Uh, and speaking about chemical methods, main question here is the toxicity. Also, it is important to have consistency in reagent properties such as pH to avoid compromised efficiency. The calcium phosphate method does not work for cells grown in media with high phosphate levels such as RPMI. Methods using liquefaction today totally depend on the cell type and culture medium efficiency. It also demands optimized conditions of transfection reagents and culture mediums. Also, these methods cannot be used for cells with thick extracellular matrix or cell wall. When it comes to viral vectors, there is a limit to the size of the genetic material that can be packaged inside the viruses. Also, the vectors need to be chosen really carefully for different organisms. The labs where such a transfection can be performed must have a high level of biological safety. So, as you can see, each of these methods has its own cons, and now let me show our own suggestion. Our suggestion is to use Agrobacterium tumefaciens for the DNA transfection. In nature, Agrobacterium introduces several oncogenic genes into the host plant, leading to formation of tumors, and in the laboratory, this microorganism is used widely for plant genetic engineering. Agrobacterium infection requires the presence of two genetic components located on the bacterial tumor-inducing plasmid, the transfer DNA, tDNA, which is introduced into the plant cell genome. Here you can see what I'm talking about. And also, it requires a wireless region composed of 7 loci, where A, where B, C, D, E, G, H, encoding most components of the protein apparatus for tDNA transfer. In addition, several bacterial chromosomal virulence genes participate in the early stage of agrobacterium attachment to the plant cell review, and the infection process begins by chemotactic attraction of Agrobacterium toward founded sites on the host plants. Attachment of the bacteria to the plant cell surface and then activation of the tDNA transfer machinery. During the attachment, Agrobacterium first loosely binds to the plant surface, then it produces cellulose fibrils that tighten the binding, and it allows attachment of additional bacteria. To transfer tDNA into the host plant cells, the attached agrobacteria uses a complex transport machinery encoded by the Vir region I mentioned before. Uh, the best uh, the best studied inducer of Vir gene expression is acetylsyrindrone, a monolithic phenylated molecule. Besides, our solution contains not the pure protocol, but actually the methodology. As you have seen before, agrobacterium can be used for plants, for even animal cells, for fungi, and for yeast. And it shows us a pretty wide range of eukaryotic cells. And now let's take a look onto our methodology. So at the very beginning, we need to prepare the host cells. At this stage, we need to incubate cell strains onto the appropriate medium. Our time may vary depending on the host cell type. Then it comes to the preparation of agrobacterium. The commonly used strains of agrobacterium are Agrobacterium tumefaciens. This one should be cultivated separately on separated petri dishes. Time again may vary from 5 to 16 hours depending on bacterial strain. And then, after these pre-cultivations, the real magic starts. Because the next step is co-cultivation of agrobacterium and host cells. After adding about of 100 microliters of the induced agrobacterium cells, we set the plates to incubation for 2 or 3 days at temperature of 27-30 Celsius degrees. Then, of course, we need to change mediums for several times, and after that, we can start transformation selection. At this step, depending on what was the transformation about, we may perform different operations. For more accurate data, a range of experiments should be performed. Unfortunately, right now, there is no possibility for us to hold such experiments. Furthermore, it requires pretty long period of time, or about 2 or 3 months, because such experiments cannot be set in 2 days. It requires a lot of statistic data. Definitely, there are still more experiments to set up. Also, it should be explored whether agrobacterium can be used for transfection of such powerful genome editing tools as CRISPR-Cas, because even though agrobacterium has its own transformation mechanism, nowadays, um, as such tool as CRISPR is really widely used and studied, and it might be pretty good collaboration of those two tools. The suggested method can be used in genome editing and further in the biotechnological process. Speaking about genome editing, this new universal protocol could help us to lower genome therapy costs since agrobacterium is not such an expensive culture and it's unquestionably more affordable than, for example, lasers used for physical transfection. To conclude, there is a universal transforming method. It should be studied further to obtain more statistical data, and the experiments are pretty affordable and do not require any special equipment or conditions. Sadly, right now, it's hard to say whether this method can be widely used in vivo, but anyway, there are a few options of application. And here you can see my references. Thank you for your attention.
Thank you. Perfect timing. You still have like 10 seconds or something left. So now it's 1 minute for opponent to prepare for the polemics, please. Okay, dear opponent, you can start the polemics with the reporter. 10 minutes.
Thank you for your presentation. I have some questions for you. Where did you get temperature and days of cultivation? Where did you get conditions for cultivation numbers in some maybe experiments or in some reports?
Thank you for your question. I get you right, I hope. You can see at my references a few articles about cultivation at fungi and yeast, number 5, for example, and number 4. There are pretty clear protocols of co-cultivation of agrobacterium and the stated organisms right there.
But sorry, will it work always by this on this protocol, or there are any limitations maybe in other cells?
I found several reports about usage of agrobacterium with HeLa cells. If you know, it's human cells actually, HeLa and HEC. And yes, there were the same numbers about co-cultivation, about timing, about temperature.
How they explain this? Maybe you can you can show to us how they get these numbers, for example, of transfection frequency, maybe.
There were several experiments, several stages of experiment with, if I'm not mistaken, from 6 to 10 petri dishes, if we're speaking about HeLa cells. And then about inserting antibiotic resistance for example, fungi or another plasmids into HeLa cells. There were options to check what's being changed.
So I read about agrobacterium that it make like galls in a plant system, but how will it work in human organisms? How it will interact with the immune system? Because I know that we have on the cells MHC that can interact with pathogens, and then bacteria will be okay. That immune system will kill this agrobacterium. No.
Thank you for your comment, but I've stated that method can be used in vitro and there is no data about using this one in vivo. I'm not speaking right now about using such a protocol in live organisms, so I have not considered this point. I have not considered the impact of immune system. The answer, the response.
Okay. So I had a question about packaged DNA. How will agrobacterium be packaged DNA? Because I know that bacteria have a CRISPR-Cas system in them, because it's like their preventive system. And will this DNA defined by any proteins? Maybe I'm not understanding now how it will be packaged in bacteria.
There are several methods of transforming the bacteria. Again, it's bacteria, so it's pretty easy to transform them. There are a few methods used for doing that, and
So it will be transformation of bacteria, but not it will be like a transporter of DNA.
sorry, but I have not finished. So there are ways of insertion the needed part of the DNA.
Mhm. Okay. So you mean that this agrobacteria will take this DNA inside her plasmid and transform it, and then it will be it will get into other cell and transform them. I not understand now. Sorry. Can you explain more detailed how it works with maybe cells of leukopid?
Uh, okay. So first of all, we need to insert the part of DNA into the plasmid, into bacteria. It's just as scientists always do when transforming, for example, plants, adding them resistance for some of the illnesses, and then agrobacterium just attaches uh, to our target cell. So
But
the first part is not the actual point of today's review because it's about transformation of the bacteria. And today we are speaking about the possibility of transformation of eukaryotic cells and how, in which way, in what way it can be done. It can be inserted into the cell, the DNA that has been before uh, transformed and inserted into the agrobacterium.
I think that when we talking about maybe human cells in vitro, if you put bacteria on this culture cell culture, it will like infection, but it's not a good way for transformation these cells because it will continue to it will lead to dying of some cells. It will be toxic, and so not only a part of DNA what was put it in agrobacteria to transform them to transport will get in the cell, but all DNA, all all uh, own DNA of this bacteria will get in our cell. I think it will have some problems because so we'll get other genes of this bacteria, not only which we want to put in.
Okay, I see your point. Thank you for such a remark. It's really important, and I believe that it's another option for performing some studies. But anyway, agrobacterium now is used for plants, so there are methods of inserting only the targeted part. And I believe that after performing a few studies with, not a few, actually, it should be a large amount of studies, but there is an opportunity to prevent attachment of unnecessary DNA parts. And I believe that there is a way to reduce toxicity. As I have shown, almost all the methods used now require some, so to say, loss. None of the methods is perfect. So it's just another way, a little bit more universal than all the others.
Okay, so I have another question. How many bacteria so you need to place into our cell culture because to transform all of them, it will be a colony, maybe it will be a biofilm, or it will be one agrobacterium. How do you feel it? What do you think
Okay,
about it?
actually, it's only the question of the amount of transformation actually performed. So if we insert one agrobacterium, there is a chance, not even the fact, but a chance of one transformation. And if we insert a lot of, so there are higher chances of transformation.
But I think that if it will be a big count of agrobacterium, it can agglomerate to biofilm, and then it will be bad, really bad for our cells culture that we need to transform it because this biofilm will attack this cell culture. So maybe
Yes,
what?
And
I'm
I
sorry.
really sorry to stop such an interesting and fruitful conversation, but fortunately the time has passed, and now I will give 2 minutes to the opponent in order to prepare for the opposition. Please.
So I can begin. Hello everyone.
5 minutes.
I represent Phoenix team as an opponent, and for the most, I want to say thanks for a really interesting decision. And I would like to notice that there was in a presentation strengths of work, like a lot of details that there was like cons of the most used methods with description of these methods. There was a slide of objective. There was of the slide of a step of the process with a really good scheme, but I think that it was a little bit difficult to understand, and it will be better to break this picture into parts and to explain it in different slides, but it's only like noticing for future. So there was a solution for different organisms, eukaryotic organisms, and there was a really detailed protocol with conditions of cultivation, of transformation, with a temperature number, with a number of cultivation days, and other conditions. And so there was planned experiment, but as maybe as for disadvantages, I can say that when were explained methods, there wasn't any pictures, and maybe it was a little bit difficult so to understand these methods, and not all methods, not all popular methods were shown. So there wasn't any graphs or any statistics, and sometimes I didn't understand where was taken different counts and numbers and percents. So and there was not really understandable how agrobacteria, which can exchange plasmids with other bacteria, will used in all organisms. That was attention about working in plants, and I agree that it's really good work in plants, but I didn't listen nothing about maybe fungi, and there wasn't facts really proves this solution about how will it work in animal cells, and maybe it will be better in future to get some statistics or some observes about uh, simple or similar systems working in cell culture in vitro. So to see how it work in picture in maybe some scheme and to have some statistic, maybe not, of course, not your experiment, but in other experiments, other reports to listen. So, and also I can say that it was a good structure, but for me it wasn't very. Uh, it's uh, has no. It was really hard to imagine all of things that we were talking because it's there were a little number of some pictures, graphics, and other.
Okay, thank you. And with this, your time has finished. And now the reporter has 2 minutes to respond for the opposition, please.
Okay, thank you. And I'm really grateful for such an opposition as well as for the polemics. I believe that we have discussed several important questions, such as toxicity, DNA introduction, and so on. Thanks for the evaluation of my graphic material, and I will take into account all your comments. But anyway, I didn't want to insert just some random pictures from different experiments, so I decided that it would be better for us to imagine what we are talking about. But thank you, I will try to work it out. Speaking about what you have said about, oh my gosh, tautology is everything. The researchers has shown the statistics, and I don't believe that even if I've inserted the statistics onto the slides, you would have enough time to analyze it correctly. Speaking about unclarity of references, unclarity of the origin of numbers at my presentation, there were the references right next to the data. So if you want, you can check it out. All the data is from the official sources. Speaking about usage in different cells, I again want to emphasize the fact that my idea is that this method can be used in different cells, and different researchers has shown this fact. In different eukaryotic cells, agrobacterium worked the same way. They did attach to different cells. They did transfected the DNA inserted into those bacteria. So this method can be worked out. Speaking about
Okay,
usage of
and okay,
methods,
you finished your thought. Unfortunately, time has passed, so now it's 1 minute for the reviewer to prepare for the reviewing.
Can I ask the reporter to change the slide to one where you describe which cell types can be used with your method?
yes.
That's it. Thank you.
You have 15 seconds left. So now, you, dear reviewer, you have 4 minutes for the review, please.
Thank you. Only say, please, are you satisfied with my microphone, how it works? Because I had problems.
Actually, yes, you have kind of problems with the microphone. If you can fix them, it will be better. If not, then like what can
Yeah.
we do?
Now I change account.
Okay, we are waiting for you.
Yeah, thank you for your attention. So I should say that the reporter solved the problem. She introduced her view of the universal method. She explained it really clear, step by step, and the presentation was divided into several parts, which made it easier to understand the idea. Um, I think that illustrates the current presentation really good. But it would be better if the reporter have introduced also an illustration of the process of agrobacterium transformation to animal cells. There wouldn't be so much misunderstanding between reporter and opponent. Um, I agree with opponent that there are a lot of disadvantages of the reporter method because we wouldn't know if the agrobacterium contaminated with another plasmids that we are not interested in, and they could kill our animal cells. Also, the contamination of the whole culture of agrobacterium is very possible because there could be brand bacteria from other species, which will provoke all the experiment. And yeah, it's pretty not. It's not really clear how it works on the animal cells. Um, and the other, what I wanted to mention, that in presentation, the reporter used references pretty old. The year that are mentioned there, it is 2001, 2005, and just several of them 2016. Not really good literature review was done. And if you can change rapidly the slides, please, to the description of methods, calcium phosphate and electroporation. Yes, thank you. As our team also solved this problem, we, in our research in the literature, have found that electroporation has the efficiency also 40%, 75%, so much bigger than you said. And it worked in cancer cells, in stem cells, and so on. So please be attentive to the references that you use. Thank you. I'm done.
You, yes. Now all three of you have 10 minutes of suicide polemics, please.
Okay, thank you. And first of all, thank you for your attention to the references. But speaking about the age of those, unfortunately, any further researches hasn't been conducted, and that was the last ones on this topic in general. And I sincerely believe that having some of them is better than nothing, and I wish there were more, but that's what we have. Another point that both the opponent and the reviewer have raised is the contamination of agrobacterium among onto other onto our transformated cells. Okay, I have mentioned that there is a high. It's really important to conduct further experiments, to conduct further processes of collecting data because there hasn't been enough experiments and the data on how many cells should be added or how many milliliters is in lack. We need to set our own experience to get the exact numbers, not to in order not to kill our cells. This question is still the one to be solved.
I would like to suggest several improvements that could work in using your method. For example, for the problem that agrobacterium could be contaminated by other bacteria species, it is the thing of the culturing. So we could prevent it by doing all the operations with the culture in sterile conditions. And I think that to prevent the problem of contamination with other plasmids, maybe we can develop a new line of agrobacterium that are free of its plasmid and just use our that we want to. Another improvement that we can use is not to incubate animal cells at least too long. I think 3 days could harm the animal culture because
Sorry to interrupt you,
yeah.
but may
But
I add a few comments?
let me present just several
Okay.
words. Yeah, so maybe we don't have use such a huge period for incubation. It's just my suggestion. Yeah, for example, neurons. If we want to transform neurons, I don't think they would be glad for it. Yeah, uh, say please what you wanted.
Okay, so first of all, thank you for your suggestions. It's really important for me to have some others' opinion on this method because I'm really interested in it and I would love to perform experiments. And speaking about the prevention of contamination, yes, cultivated in sterile uh, should be cultivated without any additional bacteria. And obviously, we could use some of the antibiotics added to the medium. It's another way of increasing the safety of this line. Speaking about cultivation, I would like to state that obviously it means a few stages of cultivation. So we do not take the very first plate, but we do a few plates, a few ways of plates. We take one plate from this one, we reset the bacteria onto another, and so on. And this process lasts for a few days. And this will give us a clear strain of cells.
Oh, thank you very much that you specified this detail. Maybe I didn't get it from your report. Yeah, and I wanted to add about antibiotics. Maybe you know what particular antibiotics we could use that wouldn't harm agrobacterium, but others will.
There are several antibiotics actually. They all can be found in my references. Unfortunately, I cannot say, frankly speaking, right now the examples, but it again depends on what exact microorganisms we want to avoid or base choose. Sorry.
May I say something? Um, I think that your hypothesis has one limitation, at least that plasmids cannot contain big long genes, but if you take part some of small genes, it maybe it will work, but if you want to transform cells with a big gene that has a lot of nucleotides, it will better to use maybe some other method. But for your solution, I think it will be better if you want cultivate to take a small group of cells that can multiply, can be uh, take in the cycle of making other cells. I can't remember this in English, sorry. But if you take a small number of cells and then you try to transform by agrobacterium, not a big number of cells, because they also can conglomerate in biofilm and it will be bad. You can then take this colony away and then catch only that cells that were transformed, and then try to transform others by uh, prevent your experiment of big размножение, big number of cells of bacteria that can eat, they can kill other cells, but it will be, if it will be small number, step by step in different plates, you can get your cells small group before and then transformed group. This will get other cells. Sorry. So
Oh,
I
yes.
tried to
Okay.
explain, but I
Yes,
have
I
a
got you.
bad English.
I got your idea. Thank you very much. And it seems to me to be really relatable and really easy to perform because I mentioned that there is a field for experiments with adding CRISPR-Cas for inserting longer DNA strands, but your method is actually more affordable for conducting experiments onto, I don't know, field, so to say, without any specific lab equipment. And thank you. I will take this into account. It's really cool.
Mm, I just wanted to clarify one misunderstanding that opponent said. It is possible to insert in plasmids well, pretty big genes. I think you messed up with the methods of viral delivering of the DNA, because there we can't replace huge plasmids into the capsids. Yeah, that's all.
Okay, and with this we will finish the polemics. So before I will give the word to the reporter, I would like to ask the jury members if they have the questions to put plus in the text channel, so I will be able to give you the word. And now, dear reporter, 1 minute for closing remarks, please.
Okay, so I thank the opponent and the reviewer for the productive polemics, for the productive opposition, because it really gave me a few thoughts to review. It really also gave me a few insights on my method, and it also has shown that this method can be taken back to life because, as the reviewer mentioned, my references are pretty old, so there is a chance to renovate them. And this polemic, this fight, was actually a great opportunity to develop my my decision, my answer.
Okay, thank you. Now we are going to the questions from the jury, and first one from Vitaly Kalinowski, please.
Okay, I hope you hear me well.
Yes.
I looked through your references and I found the efficiency of transformation for your method for human cells, HeLa cells or kidney cells, was about 1,000th or 2,000%. The same, like the worst outcome for electroporation, which is far more simpler and far more cheaper. So why should we use your method? Thank you.
Okay, thank you for your question. Yes, this method may have pretty low efficiency, but anyway, speaking about electroporation, we still need some equipment, and sometimes it's really more difficult to get the equipment than to get an agrobacterium strain. So probably this is the reason why my method would be better than electroporation at least.
Do you consider you don't need any equipment to conduct agrobacterium strain to keep it clear and to provide all these selection techniques?
Definitely for conducting my experiments, there should be a sterile lab. There should be all the equipment that is required for cell cultivation, but there is no specific equipment. Just bacterial cells, bacterial strains.
And thank you. And I wonder if you compare with calcium phosphate.
If we're comparing with calcium phosphate, I sincerely believe that chemical methods may have pretty toxic, so to say, it may affect cells by toxicity. And this is the reason why agrobacterium as a natural transforming agent could be more preferable.
Thank you. Thank you.
Thank you also for the question. The next one, and for now, the last one is from Valeria Lukashenko. If there are some other questions from the jury, I'm asking you to put plus in order for me to give you the word. So Valeria, please.
Yeah, thank you. Okay, I'm probably going to ask a very naive and very stupid question, but it's not really clear to me. If the reporter can clarify that. So what is so special about those agrobacterium? And maybe reporter or also opponent and reviewer can name other bacterium we can use, and whether there'll be some pros and cons. I mean, I'm saying as a person that has never touched any biological stuff in my life except for high school. So if you could clarify that, it wasn't really clear for me. I'm sorry.
Thank you for your question, and I believe it's really important for everyone to understand the very basics of my solution. So speaking about other bacteria, no, at least I'm not sure. I haven't seen any other bacteria that can be used in such methods. And what is so special about this agrobacterium is the fact that this bacteria can use the same method for attaching and transfecting DNA into the different eukaryotic cells, for example, fungus, yeasts, animal cells, and plants. It has the same mechanism.
Okay, so
may I answer?
Yeah. I wanted to ask if someone else might have an
Agrobacteria has thioplasmid, as I know, and these special plasmids release pectolytic enzymes by bacteria, enzymes that ensure close contact with plasmalemma, and because of this close contact, bacteria can get inside the plant cell. So not all bacteria can do this.
Oh, okay. So it's really a structure of bacteria that is really important here. Okay. I don't know, maybe I was not sure whether it was opponent or reviewer, but maybe the one that didn't speak yet can add something. If not, it's also okay. Okay, then.
Okay, thank you. As far as I see, we don't have any other questions. So we will pass to the phase of evaluation. So I'm asking the jury to send me, as usual, marks in the private message. Thank you. Okay, so I'm ready to announce the scores. So the scores are for the report 77878. For the opposition 86777. And for the review 77967. So if there are any jury who want to comment, s'il vous plaît.
I don't know, maybe I can comment. I mean, I think as for a non-expert, again, I'm sorry. For me, the fight was nice. I think the first polemics was a bit slow. The one that was only the opponent involved, at least to me, it was a bit. It kind of got on the pace a bit at the end, but then you had to cut the time. And the only problem, of course, I cannot judge the second polemic that well because there was some problems with connection. At least I sometimes couldn't hear certain things. So, but I think at least some questions that were asked there were definitely some of the ones that popped in my mind at some point. At least when the reviewer joined, or I mean, it's of course, yeah. I'm not sure how true it is actually because of this connection problem. So I kind of followed only, let's say, 50% maybe of what some people said, unfortunately. But other than that, I think it was nice. Although I would wish there would be a bit more speed, maybe because it all was very monotonic, and somehow, in the end, it somehow got a bit into like more, constructive talking. And but other than that, I don't think I have any really, let's say, negative comments or something like that. I think it was fine.
Thank you.
Thank you for your marks. Thank you for everything.
Are there any other juries who wants to comment? Seems not. Then we are going directly to the second round. You make a short break between second and third round. So Team Bazinga will be the opponent and Team Phoenix will be the reporter for this round. So the problems which can be challenged is Phoenix. So except 1, 2, 4, 5, and 7. So all the problems except 1, 2, 4, 5, and 7. So Team Bazinga, which problem you want to challenge Team Phoenix? Yeah. Can you please came back to your previous account?
Yeah, sorry. Number 3.
Problem number 3, Team Phoenix.
One moment, please. Okay. I don't remember about what
Rumble number 3 is 9 out of 10 dentist about the thermal paste.
Okay, thank you. We accept, yeah.
You accept. Perfect. So you can start doing the preparation for the report. And also, I'm asking all the teams to write down the names of all the reporter, opponent, and reviewer who will be performing in this phase.
One moment, please. We have some technical issues.
Okay, which kind of technical issues?
У меня зависает немного Discord, и у меня не получается транслировать экран. Но это недолго. Сейчас я постараюсь реконнектиться. Подождите.
Okay, okay. So I want also to say that the marks for the previous opposition and reviewing will be lowered by 10% because Daria Nikina already was opponent in one of previous fights and Valeria Vasilieva already was the reviewer in one of previous fights. So I'm just making you that you know it. Team reimaging. I'm still waiting for the name.
1 second, I'll write it.
Okay, and also Team Phoenix. I'm also waiting for the name of your reporter.
Do you see the presentation?
Yes, I see it. But so you write that presenter will be Anastasia Kulishenko, but on the presentation it's Victoria Feoktisova. So in reality, it will be Anastasia who present. Yes.
Yeah.
Okay.
Victoria didn't want to represent this.
It's your choice.
Yeah.
So if there are any person who don't see the presentation, seems not, which means that dear reporter, you have 10 minutes for your presentation and you can start right now.
Oh, okay. Hello, everyone. I'm glad to represent the Team Phoenix as a reporter, and I will talk about the task 9 of 10 dentists. So let's start. We know that here you can see the task. And here's our goals, which we set. The first is to find information about what is thermal paste, which properties are important for it. Our goal is to find information from which materials thermal pastes are usually made from, and we need to suggest a type of thermal paste. So, what is a thermal paste? Thermal paste is a thick and viscous substance with a high coefficient of thermal conductivity. It's used to improve the heat contact between the surface of the active electronic components and the radiator. Thermal paste is most often used in computer technology as it provides efficient heat removal from a central and graphic processor. Today, computer or laptop can't be without thermal paste, and if we used computer without this thermal paste, the chip would just burn in a few minutes, and it's horrible, I guess. Um, So the the thermal conductivity or thermal paste depends on its composition, which includes micro and nano dispersed powders and mixtures of metals, metal oxides, nitrates, microcrystals, and organosilicon compounds. They abound with the help of mineral or synthetic oils, and sometimes easily evaporating impurities are added, and thanks to which the paste is easily applied. And after their evaporation, it acquires a denser structure. Um, so, as metal impurities are mainly used, is copper, silver, gold, wolfram. Oxides are most often taken from zinc and aluminum. Pure metals such as indium are least commonly used, as they have high electrical conductivity. When thermal paste is created, it's important to take into account its viscosity. If the thermal paste is too liquid, it will fall out, and if it's too thick, it will lie unevenly. For use in computer technology, so it needs to have as little thermal resistance as possible, minimum obstacle to the spread of heat. Also, it's important that the preservation of properties within the declared operating temperatures, and also uh, it should have saving properties over time. Um, and also it should have chemical neutrality, as it eliminates chemical damage to the motherboard, and the thermal paste must have high electrical insulation properties, eliminates short circuit in case of contact with computer components, and the thermal paste is applied in a thin layer. I guess that it's important too, and also it's really important. Uh, yeah, it's also very important that the maximum thermal transfer is provided by liquid metal and graphite tapes. But liquid metal has significant limitations on the installation possibilities. First of all, it's applied by scalping in a very thin layer, but it's very difficult to make. And if the metal gets on other surfaces, it's almost impossible to clean them. And secondly, it must be evenly and tightly applied to the entire area, otherwise the cooling efficiency will significantly decrease. Uh, and now I guess that, as already mentioned, the most promising materials are organosilicon liquids and boron arsenide. It's a substance that has a thermal conductivity comparable to that of diamond, which is previously thought had no equal. We found this in one of the article of Japanese scientists, as I remember. Uh, so, uh, what do we want to do with our oven thermal paste? Uh, uh, our thermal paste has our ingredient, yeah. It should have transformer oil, different particles, and duralumin mm, in their oven. Uh, I don't remember the word, but okay. Um, and components of duralumin ally with the designation, and the aluminum should be about 94% copper. I'm sorry. Uh, 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 yeah. Um, um, I'm I'm panicked. I'm sorry. Um, let's go to the other slide. As you know that the electrical conductivity of the suspension itself will be determined by the electrical conductivity of the pore dispersion by the formula. And it's here all the formulas which we wanted to use. And where F is the coefficient of structural resistance, which we can find by the formula, and number two, and the volume part of the dispersed phase, it's recommended to calculate the contribution of each phase separately and take the largest one. I guess that I have no time to say a lot of this about the formulas. So, yeah. Oh, how many time do I have?
2.5 minutes.
Okay. And we wanted to do an experiment, but in our home conditions, it will be really hard to do. But we want so we can't we couldn't do some real data about this, but um, we only propose the ingredients and the ratio of them. I guess that's all. It's the most important. And yeah.
Okay, thank you. Now it's time for 1 minute for the opponent to prepare for the polemics. So the time for the preparation passed. Now you have
Do you
10
hear me?
minutes. You have 10 minutes for the polemics, please.
Do you hear me? Yes.
Yes, we hear you.
Okay, good, fine. So
I'm
I'm
sorry,
waiting for.
I hear some noise. I should reconnect.
Okay, let's wait for you to reconnect and then we will start.
Okay, no problem.
Also, if you can turn on the camera, it will be good.
Are you talking something?
Yes, can you hear us?
I
hear.
see the picture, the green ranka around your photo. What you are talking something, but I don't hear.
So you don't hear me. Okay.
I don't know. What do you talk? I'm sorry.
Okay. Okay, we are waiting for the report. So can you hear me now?
Talk something.
Can you hear me now?
I see only green. I don't know why. I don't know why it's happened. I'm sorry. I don't know. Maybe I should try one time more. I don't know. I don't hear.
Okay, we have a very big technical problems. Fortunately, the PC died. So the reporter team, I asking you to delegate someone in order to participate in the polemics. Who will be the reporter changer? Team Phoenix? Is there anyone?
I'm here, but I'm not sure if I could take a part in polemics because I have never seen this
I understand you, but
before.
I understand you, but like there are no other way to do something because the computer
Okay,
died. So
let's start then.
yes, unfortunately, but there are just no other choice.
Sorry, but can we just change mm, the number of the fight? Then, for example, our team will now represent.
Now it's not possible because the report has already happened.
Okay.
So, okay,
So let's
I
start.
try to answer questions.
Yeah, like we will do it for now, but the reporter will try to, I don't know, to make the PC alive, and then if she, because we can't really wait because it can be too long. So if the reporter will come back, then she will replace you. But until that, you will be participating. So the time is starting. You have 10 minutes. Sorry, but no other choice.
Okay, I understand.
Okay, do you hear me, guys?
Yes, we hear
Yes.
you.
Yeah, okay. So according to the reporter's speech, I would say that the presentation clearly covered the properties of usual thermal paste, and it was clear to see that the particles that are used in thermal paste are like physically proved, that usually it's like metals or metal oxides, and I would say that for me it's not clear covered the size of particles, like average scale, what should it be, like nanoparticles or microscales, what kind of size particles should we use in thermopaste. But the way to use metal particles, I think it's a good idea because it's a bit cheap. So, and it's easy to combine, but maybe in using gold or silver nanoparticles, this past will be a bit like expensive. And also, if the reporter could ask, like, have you researched about some carbon nanoparticles, like nanotubes? Because now carbon nanomaterials are good in like in electricity, like they have some properties, good physical properties in nanoscale, and nanotubes, they have very big coefficient of thermal coefficient, yeah. And maybe have you covered the idea of using non-metal particles? Because I've just seen some like metal particles.
I think it's a good idea to use nanotubes, but in our presentation, I think the author means that we use maybe cupromol nanoparticles. I'm not sure. So I think it will be cheaper and it will be better to use carbon nanoparticles.
But carbon is expensive. Carbon nanoparticles,
Sorry.
expensive. But like the idea of using non-metal particles, it's just maybe it's good from scientific point, maybe like just to cover the idea and see the coefficient the thermal coefficient, and compare like the size of nanoparticles, like metal nanoparticles, or maybe even though compare like aluminium or ferrum copper nanoparticles or microparticles, and see the coefficient of thermal coefficient in different scales. But the idea of fusion metal particles, it's clear, and I would say that team perfectly covered the idea. So like.
So may I ask you one question? If we will not use carbon nanoparticles because it's rather expensive, what kind of non-metal particles we can use? Like maybe you have an example.
But maybe I don't know exactly the coefficients, but maybe it's idea to look at silicon, like silicon dioxide, or maybe some particles with bore, like maybe there in your presentation there were covered some nitrate bore, yeah, bore N compounds, and some maybe like silicon dioxide, or maybe I don't think about tellur or like arsenicum, because it's maybe dangerous, some compounds of arsen, but arsenate of gallium is like it's semiconductor. But boron or silicon compounds, maybe it's a good idea to see and compare like silicon, carbon, bore based compounds just with their coefficient, and see maybe it's a good idea to use non-metal compounds. But of course, gold and silver, they are good, but expensive.
Maybe it will have if we use if we use gold, maybe it has toxicity. I'm not sure. Not.
But as I'm not mistaken, gold nanoparticles, they have positive like biocompatibility, like bio. So they're used in nanomedicine to catch some molecules. So silver and gold nanoparticles, as well as silicon carbon, like not carbon, but silicon dioxide. Because of using maybe some arsenic compounds, it can be maybe difficult. It can be dangerous because we need to see the percent of evaporation, because some of compounds after heating can be evaporated, and arsenic, like compounds of arsenic, is dangerous. But
Okay.
carbon is very cheap, but making nanocarbon material, of course, it's not. Maybe if you have heard about Vanta black material on YouTube, there are lots of topics about these types of nanomaterial, and it's really expensive. So I think
So
it's
thank
good
you.
your presentation. Yeah, and maybe
We
that's it
will
for
take
now.
it into mind. So
Maybe like we have
maybe
finished
you have some
our
other questions.
other questions. Maybe what about some gals in your presentation? I saw some like not hydrogels, but like maybe silicon based gels for capture these particles in the past, and maybe like to make a perfect past, of course maybe we need to use the polymer and compare the temperature of, like, not evaporating, but the temperature diapason for the temperature, like when the polymer will be very like tвердый, like not soft but opposite, and compare the amount of polymer and amount of particles and make like appropriate paste, not so soft and not like so liquid. But maybe for oils, I saw oils in your presentation. They might be useful, but maybe if we take, for example, you have a laptop and there is a silicon processor, so maybe not to use oil, and like be sure that it won't be poured out of your
It
process.
will be better, as I understand, than polymethyl siloxane.
Maybe
Yes.
maybe like some not so liquid compounds. I don't know how to say it in English, like not liquid.
I understand it, I think.
Like
Okay.
jelly-like compounds.
Okay. So oil will be better, yes?
Or I mean like
okay.
not maybe not
Silicon.
oil, but some silicon.
Silicon, okay.
But of course, silicon, they have silicon's compounds. They might have a bit water, so maybe we should be sure that no water will be evaporated, because after using like silicon gels, they are used like in clothes just to keep your clothes from water. But if you heat it, it will be not.
So
It won't have water.
it will be hydrophobic, yes?
I mean, like if you heat some silicon-based materials, the water might evaporate. So we need to see the diapason of temperature when we want to.
Okay. So thank you. I will notice it for the author. Okay.
So I think we have already discussed.
Yes, so
Yes.
then, dear opponent, you have 2 minutes to prepare for the opposition.
So may I start? Roman, do you hear me?
Yes, I hear you. Want to start
okay.
already?
Yeah, I can start.
Okay, you have 5 minutes.
So I think that the reviewer fully covered the topic about thermopaste. They have already given the most useful like compounds for general thermopaste, and the idea of using metal like metal compounds for thermopaste is it's already good idea because metals are cheap. They are cheap, and the idea to combine some oils or gels with metal particles from from technical and like money problem is very cheap. So I would say that it's pretty clear to like to see the possible ways of use this thermopaste, and maybe I would say that some questions and problems about the scales of particles that we want to use should be discussed more, and maybe the idea of using non-metal particles should have been covered before, but we could discuss it a bit later. So in general, I'm glad to hear the presentation. I think that the team did it well. So yeah, that's it.
Okay, thank you for your quite fast opposition. Now it's 2 minutes for the quasi reporter to answer for the opposition, please.
So I'm glad to listen so many points that could help our team get this part of exploration get better, and I thank you about it. I think we our author made this presentation not so well, so it can be possible to do, but most of all goals were achieved. So I will notice all commentaries that we had, and I think in future we can make this decision solution better. So thank you very much.
Thank you. Now it's time 1 minute for the reviewer to prepare for the review.
Oh, I'm readily available to review.
You want to start already?
Yes.
Then please, you have 4 minutes.
So thank you, the reporter and the opposition, for their speeches. And firstly, about the reporter. Regarding all that has been said by the reporter, I can say that the design of the presentation was great and objective on the slides, and dividing it into some tasks is also good. Critical theory points was uncovered by the reporter, and composition of the thermal paste proposed. About the cons of the solution. Firstly, numbers of the slides. It will be inconvenient to to tell you to go back to any slide because there are no numbers on the slides. You don't have any credits for images. You know, it's viable. And inappropriate data on the slide is provided, like just like metal heat conductive coefficient. You spend too much time for theory review, and regarding one slide, it was said that you will use carbon in your thermal paste, but you didn't include any points about its modification. There are a lot of them. So you have no credits for statements in your presentation. You compare. Uh, mm, you presented a lot of alloys on your slide, and I didn't really understand why do you present them, because the points of your solution was not uncovered as much as your theory was. I think it's a problem because we don't know anything about theory. We don't know about the solution while we know everything about the theory. There were a lot of Russian texts on the slides, and you haven't counted any parameters of your thermal paste, just like thermal conductivity and other parameters. You skimmed all of critical points of your solution. That is bad for your solution. And problem of electrical conductivity of your paste wasn't uncovered too. You were confident about your solution and no experiment provided. Now about the opposition. The opponent emphasized positive points of the presentation, and toxicity of the arsenicum was emphasized too. And the opponent tried to enhance the result that was obtained by reporter team. Also, constructive criticism was provided by the opponent. About counts of the opposition, there are a lot of points. The opponent haven't asked about the carbon modification, as I said. Polemics was like the opponent's monologue in some way, because mainly he talked. The polemics was unproductive. It was not about the solution of the reporter's team. And opponent designated only positive sides of uncovered solution, and summary was not clear. Thank you, that's all.
Thank you. So now you have 10 minutes for the three-side polemics, please.
So the first question will be for reporters team. Can you please switch your presentation for your solution, especially on your composition of your thermal paste?
I'm sorry, but maybe Roman can help me because I have no presentation at all.
Yes. Where you want to switch the presentation?
Okay, if you can't.
I
You
can.
can.
Just
Thank you very much.
Thank you.
Where I need to switch it?
Composition of the thermal paste.
This or this?
I think this one. Okay, you propose to use transformer oil, and you haven't compared the viscosity of the transformer oil to the other known substances. Can you do this right now?
Sorry, can you repeat, please?
You haven't compared transformer oil to other substances now regarding its viscosity. Can you do it right now?
Oh, sorry, I can't.
Okay. You're supposed to use duralumin in your thermal paste. Have you concerned about current conductivity problem of your paste?
Conductivity problem, just a second. I think it has lower viscosity, but I'm not sure really.
Okay.
Metals are good go electricity. I'm not sure. Sorry, I don't know how it's explained in English. I'm sorry.
Okay, so thank you for your answer. The question to the opposition. Is it okay to use duralumin in the thermal paste? How do you think?
I think using of aluminum I think that using aluminum compounds is a good idea because aluminum has like high coefficient of thermoconductivity. Yes, and maybe we need to compare the amount, the percentage of
I
aluminum or
see, I
maybe
see.
carbon based,
Mhm.
like just to compare.
And just for you to both reporter and opposition, can you name the best modification of the carbon to use in the thermal paste? And if you will use it, so what it would be as a thermal vehicle of the paste instead of duralumin?
Maybe I would take a look into some like fullerenes or nanoparticle, carbon nanoparticles materials. I saw in the presentation the diamond. Yeah, it was the diamond compound, but it wasn't covered like the percentage and the coefficient of using uh, the coefficient of these amounts of this carbon, but I know that nano-based carbon materials they have high coefficient of conductivity, and maybe to combine them with aluminium or some metal particles is a good idea. And of course, we need to propose the like ideal gel like to connect these particles in one phase.
Okay, yeah, I see your point, and I think that is viable. So the question to the reporter: do you consider that the point that opposition said is viable, and what do you think about it?
I think yes, because as, as I understood that cuprum and aluminium are good conductors of warmth and electricity, but I think other used dual to get less expensive this solution to get it cheaper. So we can also use maybe okay. We can maybe use some on something based on carbon, but I'm not sure because on our solution it was attended that we can will need to get our thermopast more widespread, more cheap for different people. I think.
And maybe I could add that using aluminium, like very low disperse phase, it can be a bit difficult because aluminium has like oxide layer, like on the aluminium, usually aluminium trioxide. And we need, of course, maybe to compare the conductivity of this aluminium, like aluminium dispersed, very dispersed aluminium, according like to copper, because copper usually is non-active metal, but aluminium already has the oxide. So maybe to combine like carbon and copper might be much more better than aluminium. So we need, of course, to solve the problem, we need to see the properties of each phase and compare their conductivity in different scales.
I see. So the next question to the reporter, and if you consider the parameter of transformer oil regarding only viscosity of this substance, why haven't you considered any other parameters? And can you estimate the parameters of transformer oil like heat capacity and heat conductivity? Or if not, what can replace the transformer oil in your formula? Maybe you can suggest something better.
Okay, I think it's maybe a conductor of warm or temperature of just to read it, how it will be temperature of boiling and viscosity is also important, but I think as said reporter or as said opponent, sorry, it will be better to use liquids based on silicone, and but it's also important to make our costs lower, I think.
And how do you think will your solution will be highly available?
I think the author choose this solution because she
Opponent?
Yeah, could you please repeat the question? Yeah.
Can you suggest some new substances that can be used to enhance the solution of the reporter's team?
Wait.
Or it's just not needed? How do you consider?
I'm here. So can I suggest like the ideal component for
No,
for
not ideal. Maybe some additional thing that you consider that are more viable and can enhance the solution at all.
Maybe some available ideas, of course, some like metal materials. And because using nanoscale carbon materials now it's very expensive, and to make available product, we need to take a look into some metal compounds, of course, and some possible past like gels that are not so very expensive, and of course that gels that can combine these metal particles together, and of course we need to maybe choose appropriate viscosity for the gel and make appropriate paste. And also maybe I would add that if we want to use these thermopaste on some like semiconductor devices, maybe we need to take a look not to ferromagnetic materials. So like some isolators.
And finishing
Because-
Thank you.
Yes, so before giving the reporter 1 minute for the closing remarks, I'm asking the juries if they have some questions to type plus in the text channel. And dear reporter, you have 1 minute for the closing remarks, please.
So I'm grateful for the opponent and reviewer for the commentaries, and I just try to take it out and make our solution better. So I think most of these parts of solution can take a place in real life, but as my opponent and reviewer said, we can use other substances, other nanoparticles to get maybe thermoplast cheaper. But I still think that metals like gold or copper are still expensive too, and I think we need to more experiments, more practice to think about how can get it really better, how can we get it more useful for real life.
Thank you. So we are going to the questions from the jury. For now, we have only one question from Valeria. Please.
Yeah, hi. Thank you for the fight, even though it was had some technical issues, so it was a bit improvised, let's say, for all the parties involved. And I think it's also a good experience for all of you how to improvise if something like this happens. And yeah, I think you all learned for sure something during this discussion. And I wanted to ask, I think something that somehow was avoided during this discussion, or at least I didn't get any clear understanding of this question, because also in the problem itself, it was somehow asked about, let's say, lifespan and let's say durability of your thermopaste. So I would like to ask the question to all three of you. What do you think is important for durability of thermopaste? And what are the things that can basically happen to thermal paste while using it? Like what things could somehow enforce its breakage, or something shorten its lifespan, and how could you prevent it if you could? If you understand what I mean, or if you follow what I mean. I hope you did. I don't know, maybe starting with let's say reporter, because she's let's say quasi reporter, and then to opponent, and then to reviewer.
Okay. So I think it could be spoiled, maybe because it can get dried out, or maybe it can flow out, maybe. So our thermoplasts thermoplast at all can not deal with maybe the load, and we know that thermoplast needs to not boil, so I don't really know how to prevent this, but I think if we use maybe good ingredients that could be better, we can to get really working material. So maybe opponent or reviewer can say anything else.
Yeah, thanks. I mean, it's fine because also like on your slide here, you can see duralumin, which dur stands actually for durable, like so actually for long lasting one. I don't know what it actually means for the material, but it's, I think your author already tried to think about this somehow while writing this recipe. So I can also get some information from there. And maybe opponent?
I would add that maybe to make an ideal thermopaste, we of course need to compare the period of leaving our gel that have appropriate viscosity, because under high temperature, being always heated, it should not degrade. So of course, metal particles, maybe they can, if it's nanoscale copper, maybe in some time according heating, it can aggregate and lose their thermal conductivity. So we need to compare both our polymer to switch to catch all the particles, and of course be sure that our particles won't aggregate in some big particles and they don't thermal conductivity. So I think it's a must.
Okay, thanks. And reviewer?
Thank you. And I think the paste can be spoiled in different ways. One of them is expanding while using, drying out, and if it's too hot, it can boil even. So another way of spoiling is degradation, especially if we use some kind of nanoparticles. So heat conductivity and heat capacity may be injured if the particles are stick together, and it's a problem, I think. And I think the past also can be current conductive. It's only bad thing about our thermal paste because it's conductive in this solution. And I think that's all.
Okay, thank you.
Okay, thank you. And we have one more question from Mikhail Wysotsky, which he typed. So, question for all three teams: how critical is the use of high-quality thermal paste, in your opinion? Because for many purposes, he personally uses the cheapest thermal paste, such as KTP8, while the processor temperature is not much higher, like by several degrees, within the margin of error than when using very expensive ones. So let's start with the reporter.
Sorry, I can't hear last.
Okay, if you can't hear me, you can by that time read the question in the text channel and
Uh-huh.
and
Just a second.
Opponent, maybe you will start then.
Okay.
Opponent.
Yeah. Do you hear me?
Yes.
So the question was like, which one is better, like the cheapest or the expensive one?
No, the question was if it's really critical to use high quality thermal pastes, or because like with the low quality, the temperature of the processor is not much higher, just by the several degrees within the margin of error. So is it really critical to use the high quality thermal paste, in your opinion?
Maybe I think that what is expensive, maybe it will have more time to live, like it won't degrade after using. Maybe like you just use your thermopaste at least like once per year, and then you don't need to check every month, like every 2-3 months your paste. Maybe if it is cheap and it works, I think it's good, but maybe the price means the components that are used and the period of usage the past. So if it's not important to pay more, I think it's good idea. But if you want to compare the living, like the period of use, and maybe you need to take the more expensive one.
Okay, reviewer.
Thank you. I think the question is not more about the price, but the quality per se, because as far as I know, the difference between hot conductivity of the cheapest and the more expensive pasts are up to 15% at all. And I think that more expensive pasts are more durable, and they have different viscosity because of their different composition. And for some kind of more expensive past, the viscosity is lower, that provides us better contact and heat conductivity. I think it's not mandatory to use a high price thermal paste, but it's better in some way. But it can be replaced by cheapest ones.
Okay, thank you.
So I agree with the opponent and reviewer that I think the price and the properties of ingredients have a correlation. So a good ingredients have better properties like viscosity and others. Temperature of boiling, and it prevents us use better ingredients. It prevents us for spoiling. Spoiling soon. This broke this pest. And it's also, as said opponent and reviewer, gets our thermopest useful for longer time.
Okay, thank you for all your answers. And now we are going to the scoring by the juries. So as usual, I'm waiting for the marks in the private messages. Okay, I'm ready to announce the scores. So the scores are for the reporter. Actually, it's her birthday today, so happy birthday. And unfortunately, the PC died not in the good time, but still, for this work, for you and your teammate, you get 76355. For the opposition, marks are 87767, and for the review 98778. So if there are any comments from the jury, please.
Yeah, I think I can say a few words. Yeah, I mean, now I feel very bad for the poor reporter because it's her birthday and all of this happened at the same time. So I hope she's staying strong, and I wish her a good birthday if some of her teammates can pass this words to her. And I also want to say that, yeah, it was a very strange fight for the reasons that the PC died and stuff. And but I think in this tournament, one of the things that you need to be able to do, and this is very important, you need to be able to step in if something happens. And this can happen any moment. We were talking with Roman in private messages, and we remember that actually on our first international tournament, that Roman PC actually was broken in halves at the first fight. And yeah, there was also kind of the same situation where we need to step in and, change our plans that you were before. So in principle, at these tournaments, you need to be ready to some extent to step in as good as you can into any, let's say, work of your colleague and present instead, even if it's not really your field. Like, you really need to, I don't know, either share some sort of information between yourself in a team in order to, have some idea what is happening. Or, yeah, I think this is what we did at the time. I think we kind of like gave each other instructions, that if this happens and you need to present my work, this is what is important. This is what we did. Because, yeah. But I think, anyway, it was a good experience for all of you to remember it also for the future fights and understand that this can happen and this is actual risk and that all of you have to be ready to step in. But other than that, I think the stepping went kind of smooth. I mean, to be fair, the first polemics was indeed more of an opponent's work, but I think it was also at least positive. An opponent kind of tried to explain the quasi-reporter, important points, even though quasi-reporter didn't know what was happening in the work itself. So I think that was actually good. It was somehow helpful. So, even for the reporter. So thanks. That's everything I wanted to say.
Okay, thank you. If there are no any other comments, we will have a 5 minutes break, which will start right now and which will end at, we will continue the fight with the third action in 15:35 CET. So profit for this break. So yeah, we are ready to start the third round of this fight. Let's check if everyone is present. Team Reimagine, are you here? Team Reimagine?
Yes, we are here.
Okay, Team Phoenix?
Yes.
Okay, and Team Bazinga?
Present.
Present, okay. Yulia Margorodska, are you here?
Yes, I am here. First time, I'm on time.
Perfect, perfect. Mikhailo Vysotsky?
I'm here.
Super. Valeria Lukashenko?
Here.
Amazing. And Vitaly Kalanovsky? Okay, even if he's not still here, he will join us soon, I hope. So, but we can still start the challenging procedure. Okay, okay, he is here. Perfect. So let's start. Yes, who is speaking? What do you want to ask?
Valeria Vasileva.
Yes.
Yeah, I'm just waiting. Sorry.
Happens. So team Reimagine will be the opponent, and team Bazinga will be the reporter. So you can challenge for any problem except problem number 1, 2, 3, 4, 9, 10, 12. So team Reimagine, please start the challenging procedure.
Sorry. Are those numbers mentioned about our team or not?
Yes, so you're the reporter, and the opponent can challenge you with the any problem except 1, 2, 3, 4, 9, 10, or 12. Okay, so opponent, which problem you are challenging?
I challenge the reporters team on the problem number 8.
Problem number 8, chlorella undressed. Team Bazinga?
We rejected, but again, we haven't played the second, for example.
It doesn't matter. Like, so the idea of challenging that the team opponent cannot challenge the problem which you already presented or which they already opposed. So most probably problem number 2 was okay. So let me check. But what do you like? You say that you didn't play problem number 2?
Yeah, we didn't.
But for me, it's written that you played problem number 2 in the first fight.
No, we haven't presented.
Our team was opponents on the second problem, so we can't play it.
Doesn't matter even like this. So still, problem number 8 is tactical rejection.
Yes.
Okay, next challenge.
We challenge the reporters team on the problem number 11.
Problem number 11, spellivery.
Yeah, we accept it.
Okay, perfect. So as usual, you can start preparing for the report, and I'm waiting for you to write down the names of the reporter, opponent, and the reviewer.
So, hi, can you see the screen?
Me, yes. So if there are any person who are not able to see the presentation, okay, for now it for me seems strange, or it should be like that.
Now,
Okay, now yes. So I'm asking second time if there are any person who don't see it. If not, then we are starting the report. So dear reporter, you have 10 minutes for the report, please.
thank you. So, hi again. My name is Anna Horinova, and I would present the team Bazinga with the problem delivery. So, talking about overall like drug delivery systems, there are actually some requirements which they have to follow. For example, they can boost the concentration of therapeutics comparing to the chemical therapy. They should penetrate the tissue really good. The payload stowing should be really great, and the most important one is that we can have to navigate its movements. And also, the materials which used in the system should be really biocompatible and biodegradable, so that would be any harm to the organism. So, but thus we see that sperm hybrid micromotors are really good variants because they have really great mobility, and they are actually biologically safe objects. It cannot be dangerous for the organisms, even in unusual environments such as blood, lymph, or anything else. So let's briefly discuss the model construction of the sperm hybrid motors. The general is the sperm itself, the nanomicromodule which contains the dose of any drugs we wanted to have in the driving part, and the mechanism which creates the movement and which creates a safe environment for the sperm, which is which can be like for now is microtube or any type of microhelix and like sensitive for the environment's scaffold or tetrapod scaffold. There are a number of these which are really exist. And as a rule, the movement of sperm hybrid macromotors is regulated by the factors of the movement of sperm itself, such as chemotaxics towards to a specific type of cell or tissue. Reotaxis, the movement like against the force of the flow, and stigmataxis, which is really close to the walls if we're talking about like vascular walls, for example. So what we wanted to do is to use the sperm hybrid micromotors in different usual environments. There are actually some limitations to this, of course, because the flagella itself is sensitive to some external forces, which could be like the, again, vascular walls, which creates and and the force which creates the flow of the liquid inside in these walls. So we would like to discuss the environments which could be which sperm hybrid micromotors could be in. It's blood, lymph, stomach, and intestine, and urine bladder. So the first one could be blood. What we know about it is that it consists of plasma and blood cells, and this kind of creates some obstacles for spermatozoid motion. For example, there is the stream in blood, and the blood flow, like velocity, is higher than the spermatozoid would have. So it would have to follow the same direction as the blood flow has. what we can do this here is to use some like magnetic field to hold the sperm-inhibiting micromotor and to rule it inside the blood vessels. But the problem is arteries, which have really high bloodstream. So we cannot actually use the sperm-inhibiting micromotors here, but inside some arterioles or maybe again use the magnetic field. And in the blood, macromotors are really difficult to track. But here we can use some ultrasound, so which is actually like a good method, like its name photoacoustic method, which could really help to track where is micromotor we have. What is similar to blood, it's lymph, but the composition it's kind of different, of course. What we have here is no red blood cells, but only lymphocytes, and we have less protein in the lymph compared to the blood. So we assume that here it's just no need to use sperm micromotors because some synthetic micromotors could be really better for this goal, for example. The main problem to use micromotors in the stomach is of course the low pH. What we can do here is to use the zinc and magnesium, which could reduce the hydrogen ions in the gastric acid. And with this in mind, the molecular hydrogen is actually released, and this could propel the micromotor itself along on its way. So we can use a capsule which could have the magnesium and zinc inside, and this would actually work as a motor for our micromotor. And also we need some pH sensitive cover, which again could first of all protect, but then kind of dissolve in our environment to bring the spermatomotor to its first goal. Then we have intestine. So here's the problem. The main problem is that the target can be located like anywhere, and we can't really it's hard to protect the sperm from the alkaline pH inside. So the solution here is to use some thick cover like capsule, which could help to dissolve kind of slowly. And again, here we can use zinc as a motor to move somewhat faster here. The last one, which we propose to think about, is a bladder. So the problem is that the urine is actually immobile, which produces a problem for our micromotor because it would just move chaotically inside the bladder, and it is hard to control it. But what we propose here is to use some magnetic field. So what we're gonna do is kind of rotate it, so the micromotor would follow this movement and would kind of induce this spiral movement. And then we kind of inject some solution with our micromotors inside the bladder with a catheter, and use a magnet to control the movement of micromotor to some specific sites of the bladder, which where we have our goal. But there is less experimental data on this one. It was experimented only with mouse. So some potential experiments on like human organism could be done. And something about the potential application like against some specific diseases which could sperm micromotors help to carry. So the potential is big for some gastrointestinal diseases, which in some aggressive diseases have really maybe sometimes toxic drugs which could our micromotors carry itself. Of course, the circulatory system diseases, there is a number of experimental data on usage of heparin against any diseases which could occur, Troms or yes, mainly of course Troms, and we also could care the heparin against some bladder infections, which was not really discussed before, but we see some potential here.
Please finish in 10 seconds.
Yeah, so to conclude, we would recommend to increase sperm speed by any method which was proposed, to develop some capsules which could which create a safe environment, and try to track in vivo the direction of our micromotor, and also to consider the bladder as a good environment for micromotor use.
Thank you. Now it's 1 minute for the preparation for the polemics.
I would like to request an additional minute for as a break.
Okay,
Thank you.
it's called timeout, by the way.
Yes, sorry, I didn't point it out before. It's the main literature which is used for the creation of presentation.
So a minute of preparation has passed. Now the minute for the timeout started. So your time has passed. Now you have 10 minutes for the polemics, please.
Okay, so good afternoon. My name is Daria Shishko, and I represent Team Reimagine as an opponent. Dear reporter, I would like to discuss a few questions with you now, according to your presentation. And the first one is, first of all, could you please return to your second slide, if I'm not mistaken, where you have the structure of sperm hybrid micromotor.
Yep, here we are.
Thank you. And tell me, please, what do you mean by nanomicromodule dose of the drug? How is it going to be injected into the spermatozoa?
I mean here that the composition of like what we have here is is the head of spermatozoid, and as we think, it would be better to place the drug inside the head of the spermatozoid, which is really like safe environment here and near to the nucleus of the sperm itself. And also it would be like on the not internal but external side of the micromotor. It would be like covered with any type of coverage, which is would be better for the yes.
Thank you. I got your answer. Thank you. And I also have a question. You stated that uh, the environments where the spermatozoa can be used, these micromotors can be used, are stomach and, if I'm not mistaken, bladder, right?
Yes.
My question is stomach and actually intestine, it's a caving. So how is the spermatozoa going to move there? I'm not sure whether there's liquids where the spermatozoa can move into.
So inside the stomach we have a lot of liquids, the gastric acid, the mucus around the all walls of the stomach, and it is also actual for the intestine, and this mucus with supporting liquids. It is, in my opinion, an perfect environment for the sperm hybrid movement.
Okay. And speaking about intestine, it's a cavity anyway. How are you going to use sperm hybrid micromotor in there?
I agree with you. Is it is kind of cabbage, but again we have here a mucus, and if we would use any type of controlling the movement of micromotor, for example, the magnetic beads, which would be together with micromodel, you could control the movement using this, or like ultrasound, which is also usable in some.
Okay, but as you know, it's a little bit deep under our skin, this cavity. And tell me, please, are you sure that ultrasounds and magnetic fields are going to be strong enough to get to the spermatozoa, but weak enough not to damage our body?
As it was like already investigated in this area, the magnetic field, which is enough strong for the micromotor to move, it's not strong enough to some kind of damage the organism of human. Another problem here is maybe the material which is used for magnesium, for example, zinc or magnesium. Again, it's not very toxic, but if we use just a lot of them, for example, in case when we need to use a lot of micromotors to try to leave the goal, it could be sometimes toxic, yes.
Okay, but anyway, as you mentioned, there will be mucus and it's pretty viscous, and aren't the spermatozoic movements going to irritate or to cause irritation of our intestine? Additional irritations cause even more hurt?
I hope no, because the speed of the sperm itself is not high enough to the speed and the size of the micromotor is not like big enough to really damage. Because
Okay. Is there the same pH level, and will the spermatozoa be stable in this environment?
You mean pH in the intestine?
Yes, it because as I've understood, you are going to use capsules, right? Capsules for a little different environment, right?
Yes.
Okay, so what's going to happen? What is going to happen there in this case?
Um, Sorry, I didn't understood your question totally. Can you make kind of?
Okay, we are speaking about intestine,
Yeah.
and there will be a little bit different pH from the. It will define from the one in the normal environment for the spermatozoa. And yes, how are you going to deal with this point? Because isn't the spermatozoa going to simply disappear?
As you said previously, yes, we're gonna use the capsule, which would contain the polymer and maybe some nanoparticles to protect the spermatozoa from the different pH.
Okay, but here you have a different solution. Right here on your slide, you have a different solution, don't you?
No, it's as it said, we would use the polymer, which could be really thick enough to help to protect the sperm from the pH, and then is it going to like on its way, this polymer could dissolve in the intestine, and we hope that if we're gonna if we have enough of spermobots, some of them which could be really safe and be there on its goal.
Okay, let's move on. Another question is how you're going to insert your sperm hybrid micromotors into this part of the body, actually. But I believe we can leave this question for the suicide polemic. And the question that bothers me really a lot is speaking about small vessels. Yes, you mentioned that you are going to control your sperm hybrid micromotor by magnetic field, but is this method of controlling completely safe? Is 100% of safety that your sperm hybrid micromotor will not run away from your controller?
I understand what you mean. I think that it's really depends on the environment which we wanted to investigate.
I'm speaking about blood.
About blood.
Right now, yes.
So yes, if we when we are developing our spermobot, if inside like it have enough of some metal-like material could really react to the magnetic field. So why could it run away from us?
Okay, so you state that this is a completely safe method, right?
Yes, I would say. I mean, if we regulate the power of the magnetic field, or if we're using ultrasound and regulate the power of the ultrasound, then it would be really safe, in my
But
opinion.
what if the flow of the liquid? Okay, thank you.
The time has passed. Now, dear opponent, 2 minutes to prepare for the opposition.
Okay. Okay, so now I'm ready to present my opposition.
Yes, you have 5 minutes.
Okay, thank you. So again, my name is Daria Shishko. I represent Reimagine team, and now I am going to opposite the solution by Bazinga team. First of all, I am thanking the team for such a pretty presentation, even though they were a little bit of.
I will need to stop you because there are one jury who don't hear you.
Again?
Yes, and this is actually even the same jury as before. So I don't know why this sometimes happen. Okay, now it's okay. You can continue.
Okay, so speaking about the presentation, thanks to Team Bazinga for such a colorful presentation, and thanks for developing a pretty cool solution. I also would like to state that there were a clear list of the problems, and there was actually a clear list of answers to those problems. But I have several points that really shocked me. First of all, I saw no references to the pictures. Like there were simply pictures, but there were no references where they were taken from, and it's, as for me, a little bit inappropriate right here. Also, there was one fact mistake because the last slide, speaking about the application, that it was stated that the Crohn's disease is located at one concrete point, one specific point of the digestive tract, and it's actually not true because it can be located anywhere of the digestive system. Also, there were several questions that seemed to me a little bit unclear because, for example, there was not mentioned how the drugs, the spermatohybrid motors will be injected into the organism. Also, there were a few unclear points about how it's going to deal with different pH. It wasn't said actually about the biocompatible materials. There was a statement about using such materials, but I didn't see the name of the material. Also, I didn't understand what is going to happen with the spermatozoa because it's a protein in highly acid or highly alkaline environments. And it's pretty unclear for me what will happen if the spermatozoa, such a micromotor, will appear, will be set free inside small vesicles because it can cause the formation of clusters and cause even insult or infarct. So that's it for now. Thank you for your attention.
Thank you. Now the reporter has 2 minutes to answer for the opposition.
So thank you for your kind review, I would say. There was a lot of details about, so I would try to answer it step by step. About references to pictures, that one which are more like picture like it's the pictures we designed ourselves. About first one, it was taken from the reference A from our literature. I'm really sad that it wasn't written there.
yep, here. So about the application in a Crohn's disease, it is a really good remark. Our team knows it, but we just decided to kind of point out which part of the body we could direct our spermobots to try to cure this disease, specifically like for example the here. About the ways to insect the spermobots inside the organism, it depends on the body parts which you wanted to cure. For example, if it's some big organism or organs such intestine or the bladder, it would be better to use catheter to place it there, or in the case of intestine, it also could be used if you beforehand place it in the stomach and and it will transport itself just naturally. In case of vessels,
And
it also could be used with catheter.
yes, I need to stop you. So now there are 1 minute for the reviewer for preparing to the reviewing.
So, hello everyone. Again, I will represent Phoenix team as a reviewer, and now I want to start. So, what's about a reporter? I would notice that there were different uncovered themes. So I was glad to see how spermata hybrid micromotors made. So how can it move and what different kinds of toxicity can be. Also, there were points at the first slide. What is important to discuss in this case? So also there were different schemes and there were detailed explored and represented how this solution can realized in different fluids, not only in blood. So in each liquid, it was explained how to overcome limitations. Also, the scheme how made transformation with manganese or zinc, how to reform this solution, and also explains potential applications for specific disease. There was a great table with chemistry of medicines that I think is very important. And there were used a huge number of new sources, new literature. That's good, I think. And I think it's all in all it was the most complete solution. But there weren't like of conditions. So there weren't references and illustrations, and the table was a little bit small for reading. It wasn't so comfortable, and there weren't say how introduced inside our spermatozoid, how deliver it on targeted basis, and which polymer for prevented will use in this solution. Also, I misunderstood which material made of pH-sensitive water in the slide. I don't remember a number, but we can discuss about it. And there was a graph which I understood was placed why it was placed. So polemic was really in the polemic there was really good questions that were appropriate, and I think these questions helped to look from other side and would help to make more available this solution. So what about opponent? She noticed different points that can be can broke experiments and can broke this solution in different parts, but no improvement was suggested. But after opposition, reporter could find itself.
Okay, thank you. So now you have 10 minutes of three-side polemics, please.
Can I ask a question? How you introduce inside this spermatozoid? Injection or anything else? How to target it? The liver targeting? Sorry.
So it's a question for me, yes?
Yes.
Okay. Our main focus here would be like to use the catheters because it is in the case of blood vessels, it is more comfortable to like if we know which vanilla, for example, we need to target. We could just insert the like. Some microballs inside using it, or maybe using even like some just injections. And also catheter is good in case of bladder and intestine.
Okay, thank you. Dear reviewer, may I ask an additional question on the same topic?
Yes, of course.
So let's imagine that you injected your sperm bots into whatever, for example, blood. Tell me please, how are you going to realize to apply your methods of controlling the movement in such conditions? At what point should the controller be added? Should the magnetic field be used? And wouldn't it be actually too late before or the flow of the liquid would wash the injection away?
That's a good point. I would say that according to the structure of the sperm bot itself, we should inject the material which is sensitive to the magnetic field first of all when we are when in the same time like when we have to do our coverage or and some sort of motor. We add this magnetic sensitive material to it, like for example a cap, and then when we inject it to the body, as you said, like for example in the blood, then immediately use the magnetic field, which would be strong enough to control its movement, to direct it. I agree.
But how, sorry, but how can you do this better, do this stronger? What should you make with this magnet to make it so strong to go to the stomach or to intestine? It's really deeply in the body. How you prevent? Yes.
What do you mean here then? That
I
it's
mean that stomach and intestine is really deep in our body, not under the skin. And so magnet should be really strong. How can you deal with it?
And an additional point, actually, what is the guarantee that you've caught the spermatozoa into your magnetic field or ultrasound field?
sorry for the reviewer. Could you please repeat the question? That was some noises. But
I asked about how can you improve what material maybe made this magnet, how can you improve this solution to make this more stronger to get into deep parts of body like stomach or intestine, because it's really hard to manage in this part of body.
If you're talking a magnet which would create the field itself, then we should use just some maybe bigger magnets which could affect the body and the macromotor itself. And
but maybe sorry maybe
No.
it will be cheaper or more it will be easily sometime in some sometimes use pills maybe in case of stomach or intestine, then use this technique, because I think if we use big magnets, it's really expensive and it needs. What do you think about the cost of this technique?
And safety, and safety for the organism.
And safety, yes.
Of course, like the cost of the technology is a good question, but because there are like number of steps during the production, for example, it is really like not costless. But what did you say about the pills, for example? I would say that they are good for diseases which we can really treat with pills for now, but there are a number of cases which for which just pills or some like liquid injections don't help, and there we have some problems which like theoretically could be solved with use of this methodic. And of course, if some people have the great problems which couldn't be really solved, then here we should try to it with some more like the antonym for the cheap technology. Sorry for my English. And about the safety, here we should like just try to find the best material which could be safe for the organism itself. Some polymers which could not affect the body. Talking about the magnetic sensitive materials as zinc or magnesium. Magnesium, it is a really good one for that, as it was mentioned in the literature that I searched for. But the topic which I would also like to discuss is the safety for environment, because like as you mentioned, the some of the steps during the producement of such technique would be not such friendly for not only for human but overall for environment. Maybe you could propose some developments for this technology.
Okay, dear opponent, maybe could you help a reporter? Maybe you could suggest anything that could make this solution better.
Actually, I had another question on the solution, but okay. Speaking about environment-friendly methods, okay. First of all of these should be performed by with with usage of biosafety standards, because actually causing more troubles is a biggest environment problem as for me. So let's just concentrate on the fact of saving the whole planet safe and using the appropriate methods and appropriate materials.
Yes, of course. And you also wanted to.
Yes, there was another part of your solution about immortalized spermatozoa, if I'm not mistaken, if I'm mentioning it correctly.
Immobilized, yes.
Immobilized, yes. Tell me please,
was mentioned about
first of all, how are you going to get that one immobilized? And actually, how is it going to even survive to keep its structure in the urine? Speaking about the the influence, sorry, of the environment, of the pH, and so on, because as we know, it's a protein and it may degrade very easily.
What do you mean talking about the environment?
The first part was about actually immobilizing the spermatozoa, and then we will refer to the second.
Okay, thank you. So about immobilized spermatozoa, examples could be, for example, if we have there are like number of drawbacks of spermatozoa. For example, in human, some of them have some defects in flagella or just movements overall. Also, we can use some immobilized or less mobile spermatozoa from different organisms. There was some information in literature that we could actually use like number of different spermatozoa from different animals, for example.
And with this, we will finish the discussion. It was very interesting. So for now, I will ask the juries if they will have some question to put the plus as usual in the text channel. And dear reporter, you have 1 minute for the final or closing remarks, please. Dear reporter.
Yes.
You have 1 minute for closing remarks.
Oh, sorry. Yes, so overall, I would thank you, the both reporter and reviewer. The discussion was really pleasurable and productive, in my opinion, because a number of points was discussed here. For example, about the injection, which could be really rewatched again, and about the use of spermatozoids or like sperm hybrid micromotors in the bladder. This is the technology which is really new to us, and there are like some not a lot of experimental data on this, so the technology could be really improved, and with some ideas here we can maybe think about it more in this solution. So I'm really glad that we discussed this topic because it was really interesting. The sperm hybrid micromotor itself, this technique, this overall is like promising to us and in the sphere of medicine. So it was great to discuss it with you.
Thank you. So we are going to the questions by the jury, and the first one from Vitaly Kalanovsky, please.
Okay, guys, there is so much I would like to tell you how wrong all of you are. But to cut it short, I have short questions to each participant, so please respond also in short. First of all, reporter, you mentioned that we do not need such sperm motors for lymph because they will move along the flow of the fluid. But still, you propose to use them, and you make some plan to use inside the gastrointestinal system, where they will also move along the general flow of food, water, whatever. And for decades, there are techniques to swallow cameras, swallow targeted the liver system, and so on. So why do you need it for stomach and intestine?
Thank you for the question. Answering it, I would say that, of course, there are a number of techniques which are used for the stomach itself, but the all targeted delivery systems are developing now, and is just one more technique which could be used, and maybe it would have more potential in delivering the drugs to it. Maybe with some experimental data we could develop it.
Thank you. Then, opponent. We have heard much about the ways to inject sperm motors, but how do you think? Is there any technique or possibility to remove these sperm motors after they have done what they should have done? Because maybe there is a trend for them to accumulate in specific parts of the body, like bladder.
Actually, this is the question that bothers me too, because as I mentioned, spermatozoa can even cause some clusters in the vessels, and frankly speaking, the only possible way I see is the destruction of the spermatozoa, but I still have no idea how to remove the additional parts, for example, those nanocapsules, or I'm still not sure about the polymers the reporter has suggested. So it's an open question for me as well.
Okay, thank you. And reviewer, could you please just a few words? How do you think? Are there any will be there any adverse effects from the body? Will be there any unwanted reactions from the body when you will inject cells, sperm cells, into the bloodstream? Thank
I think it can be allergy, and also these spermatozoids can sh- can interfere to blood uh, blood parts like erythrocytes uh, go into the vessels, and also they can make maybe when they drug put drug out into the blood, then they conglomerate and make um, um, like cholesterol make a plaque maybe.
Okay, thank you, thank you.
Thank you for the question and the answer. The next question is from Yulia Morhorodska, please.
Yeah, hi. So my question is, as I understand, your solution is to cover spermatozoid in some polymer and guide it magnetically, or to anyway to have immobilized spermatozoids or some sort of those things. In this case, why do we need spermatozoids at all? Because there are many other techniques that use magnetic guidance, let's say polymerosomes, lysosomes, dendrosomes. Like there is such a variety of tools that I don't see the point to overcomplicate a spermatozoid construct at this point and cover it with something and use the same techniques to get exactly the same result you can get with any other system. So could you please defend your concept in this point?
Thank you. It is a good question, but for example, if you're talking about immobilized spermatozoa, it was suggested only in case of bladder, and again, we kind of use the flagella of the spermatozoa using a magnet, because we can here control the specific movements of spermatozoa. But you could do exactly the same without spermatozoid. You can control nanoparticles, you can control liposomes, you can control a lot of things magnetically. Why spermatozoid? Here we just discuss this technique in different environment, and the bladder came out in our mind because there are a number of problems with bladder diseases which is sometimes hard to treat because of the a mobile environment. So using a spermatozoa is just a suggestion. Maybe it would work better, but because of the lack of experimental data, it is hard to say whether it actually is or not.
Yeah, I understand. I mean, it's a difficult question to answer. Anyway, I think actually we have an author of this question with us, so I would like to hear his answer after we finish with this.
Yes, perfect. So, and the last question from Valeria Lukashenko, please.
Yeah. Oh, yeah. Hi, everyone, again. Thank you for this fight. I'm still not an expert, unfortunately, but I heard a lot of talking about magnetic field and the dangers of how powerful the magnetic field is, etc., and how can we be sure that it all works okay. So I first would like to ask questions to opponent and reviewer. What is the magnetic field they think is dangerous for human body? For example, in comparison to the Earth's magnetic field.
Unfortunately, I cannot answer to this question with numbers without doing
but in
additional
comparison
research.
In comparison to Earth's magnetic field, so it's not like a number, but for example, I don't know, half of Earth's magnetic field, 2 of Earth's like approximately. Have you any idea what it could be?
I believe that it should be not more than probably a half of the Earth's magnetic field, but it still should be checked and it should be measured by experts in the labs.
Okay, thanks. And reviewer, any other ideas?
So previously I thought that magnetic field at all has no some managing for damages. It can make us it can't get damage in our body, but I think the opponent and me meant that if this magnetic will be not so strong, it could the spermatozoid could go away, and it will be too strong. Spermatozoid could maybe, if it has some metal parts, go into the broke the vessel and make damage by a metal part. But at all magnetic field, I think it's not bad for our health.
Okay, yeah, maybe I misunderstood because I had this feeling of like a lot of discussion about magnetic field and I couldn't maybe follow it so well. Thanks for clarifying that. And then I had a different question to the reporter, which somehow connects to the stuff you discussed right now, but I kind of, so you somehow inject those motors into the body, somehow some technology exists, but I still assume there'll be some probability of failure. And so, if so, what do you think is necessary minimum probability for a bunch of the sperm motors to succeed? Like, for example, you want, I don't know, 99% to succeed and that will be okay. Or you want, for example, to only 50% to succeed and then 50% might, fail on the way and that still will be okay because, it's just enough.
Okay, I would say thank you for the question. Like it is really great because when we are talking about medicine, it is like first of all about the productivity and efficiency of the method. But I would say that we here need some experimental data because it's hard to say that, for example, that in blood it is like a universal method to use these micromotors, because we still don't know like whether it is really universal for each human, for example, that it would react react normally, or it would some allergic reaction. Like some of these factors could occur, but I would say that as chemotherapy is how to say it, you use it periodically. So if you wanted to use this method of drug delivery, you just like try it, and then if it go okay, you can maybe make some regulations in dosation. For example, if the first try was okay and all of your 20 spermavotes work ideally and like fight the target, then you can use additional number of them, and then additional. If it's less, then maybe regulate it. For example, if in blood it is a bad idea to use a bigger number of them. It is probably a good idea in a stomach where spermavotes are like less maybe aggressive for the organism.
Yeah, thanks.
Okay, thank you. Now I'm waiting for the marks from the jury. Okay, so I'm ready to announce the marks, and the marks are: the marks for the report 57745, the marks for the opposition 68758, and the marks for the review 67867. Okay, so first of all, I want to tell that at 5:10 p.m. will be the announcing of the results and the announcing of the finalists, and also the choosing of the problems which will be presented tomorrow in the final. And this will happen in the general voice channel at 5:10 p.m. CET. And so by that time, I first would like to ask the jury members to do some comments on this round or in this fight on total. Yes, please.
It's possible. It's a last.
We don't really hear you well now.
Let someone else talk.
Okay, I think Vitali asked us to let someone else talk, but I'm not sure.
Okay.
I think.
Well, I can comment on my notes for the past round, my scores that I gave, and in general, well, I would like to hear Vitali's comment because I have a feeling he was the person who composed this question.
I also had
So,
that feeling.
So I have my own vision of this question, so that's why probably my notes for the previous rounds were much higher. And yeah, in general, I just would like to know the perspective, because I feel that a lot of the solution that the team proposed actually was somehow very unviable and unrealistic, and basically they just try to stick sperm somewhere in a way that it would work, some enzymatic motors which only work in lab and not in actual in vivo studies. I doubt that there would be some kind of gradient with magnesium anywhere. So yeah, that was my main problem with the discussion that was for the last round of the questions.
Now? No? Do you hear me? No?
Yes, now it's okay.
Oh, perfect. So, no, Yula, that was not my question. I had no relation to the composition of these questions. But anyway,
In general, like it seems like you have pretty strong opinion on what the right answer is supposed to be. I'm just curious of what it is up to.
it's not about
In your
right
opinion.
answer. It is about the amount of mistakes. Because all the participants behaved like there was no immune system in our body, which would immediately act on everything that you inject into the bloodstream, which you would put even onto mucous surfaces like intestine and stomach. And basically, the reporter was inconsistent in their speech, saying that we should use it in lymph and not in the gastrointestinal system and vice versa. Also, uh, overall, the lack of scientific background is a major flaw of everyone who participated in this fight. Because the things that we heard about the magnetic field, I really appreciate the question about what is the power of magnetic field. Because I advise all the participants to read something about MRI and the fields that are used there and their influence on human body. To read something about how our bodies work, about how everything is attacked, how we protect from anything foreign. I would maybe close eyes on this if you would like to inject your sperm bots into some hidden from immune system place like cerebrospinal fluid, but you don't even look at such type of fluid. You just think it doesn't exist. So overall, I think that my marks, my grades are even too high for this fight. And they are a small gift maybe to all the participants. I really would like that everyone would do their homework better. Thank you.
Thank
Sorry.
you. Julia, if
Okay, I take your criticism here. Yeah, that's right. Well, okay, thank you for commenting on that. Thank you.
Sorry, I'm the reporter. Maybe also comment on the jury's remarks.
yeah, like now it's like
Yes, of course. Just to talk about it. About talking about the immune system, of course, there are some problems about the maybe like materials which are used to coat the sperm itself. But the spermatozoids are actually have the like receptors on its surface which protect them from the
Oh my God,
storms
you're
of the
so
body.
wrong. You're so wrong. You're incredibly wrong. Don't do this, please. There are a lot of autoimmune diseases which are caused when the immune system can reach the spermatozoa. There is a blood-testis barrier which protects sperm cells from the immune system. So they should not contact the bloodstream. Never. Under no case. Really.
But just there are like a number of experimental data which like tried to use these methodics and it's sometimes it works.
What works in vitro, not necessarily works in vivo, really.
But there was even experimental data which was tried in vivo, for example, for mouse, and it works, and it really didn't like didn't really cause the reaction of the immune system, in my opinion. Sorry.
Okay, let it be so. Just try to review the literature a little deeper.
okay. Thank you for.
Sorry, can you explain about magnetic field because I misunderstood yet? I thought that about MRI that magnetic field is not so dangerous as radiation maybe, and I thought that the influence is small, but
Yeah, I mean, I cannot say for Vitaly, but I think there was an answer of opponent of half of the Earth's magnetic field, and Earth's magnetic field is incredibly, I mean, you can say incredibly weak compared to MRI field, which is like, I don't know, 1.5 Tesla or 2 Teslas. It's something like that. And your Earth's magnetic field is very, 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 very small, like even in.
As far as I remember, Earth's magnetic field is around 1 Tesla, no?
Yeah. Sorry?
Yeah, the Earth's magnetic field is around 1 Tesla. So it's,
Yeah, but like MRI is you have a 3 Tesla or so.
No, modern MRI devices are about 3 to 4 Teslas.
Oh, okay.
And Earth's magnetic field is less than 1 milli-Tesla.
I think it's 20 micron Tesla, but I'm not sure.
Yeah,
Earth's
correct.
magnetic field is really low. So what I wanted to say also with the magnetic field problem is not so much a problem of how much is it the magnitude, but like how this thing gonna permeate the cell, because if you use it too much, it might just break through, and that's not a good thing to have if you have some magnetic particles and they are you use magnetic force that is too high, that's probably will cause some damage just by magnetic particles going through the cell straight through, like depending on their size, obviously.
Yeah, I mean, of course, if you have some small metal parts in your body, and yeah, I wouldn't know what's going to happen with that. But anyway, MRI, for example, you can still have, prostheses or something like this and still do the MRI, and I don't think there are any problems with that, but you can correct me if I'm wrong.
Yeah, size is a major determinator here, because if we're talking about something that is like up to 8 nanometers or like less than 10 nanometers, that's obviously different stories than a couple of hundred of nanometers, which can cause significant damage. And I think sperm cells are not a nanometer scale. I'm not sure what the scale is, but they're quite big. So there is a problem with macrophages. In general, I believe so far, in my opinion, there is no good answer to this question, because everything you look at is basically has lots of flaws in any design you would propose. So it's kind of one of those questions that whatever you choose, you're actually wrong. So I was hoping that there is a person who actually knows the right answer.
Well, at least you should have used these spare motors not in the medium which already has some flow. Because if you have, they use spare motors to make some directed movement. That was they reached in the female reproductive organs. You don't need these spare motors for blood, for lymph, for gastrointestinal system, for bladder, whatever. Maybe cerebrospinal fluid, where the flow is really, really low. And maybe some, I don't know, cavities of some tumors, but really one of the more, maybe abdominal cavity, but nothing more. For some reason, all the participants focus on blood.
Yeah, it's true. No one really talked about cerebral fluid and possibility of using it there.
So it was necessary to suggest anything else in this case? Not a spermatozoid, not spermatogybrid micromotors?
I suggest it would be better to rationalize your choice and to correctly find all the drawbacks of your solution.
Yeah, I guess for future, if you have a question like that and you believe there is lots of things that you cannot solve. You can just probably really, instead of trying to just fit your thing into some sort of box and to make it fit somehow, just try to use logic in order to say why you think this cannot work and that cannot work. And even if you don't find the right solution, I think it is the way your thought process goes is much going to be much more appealing than presenting a solution that is somehow fabricated to fit into whatever criteria. I think that's a much better strategy. Like if you have a good justification for what you're saying, I think any judge would appreciate that.
So if the task little bit strange for you, you can say that you can explain why it doesn't work, and then to suggest other solution. I think.
Yeah, well, you should have just gone. Well, this is a sperm motors. Here's their advantages. Here is a type of fluid that exists in our body. This is a fluid A, B, C, D, E, and here is how and why we can or cannot use this particular set in this particular fluid. So you have omitted a couple of fluids. That's why your answer wasn't complete. But if you'd say you mentioned cerebral fluid and you find that it is not suitable, you just say so. And you say, oh, I find that this is also not suitable because X, Y, Z. And that would be fine. I believe so. Like if you would consider every single part of the fluid and you would say why yes or no, you can use it, that would be absolutely fine by me. But I don't know. I cannot speak for everyone else, of course.
So thank you very much for commentaries.
Yes, thank you for all remarks. It was interesting to hear some ideas.